Okay, this is 3.4 day 1, and we're going to use like bases to solve exponential equations and logarithms to solve them as well. There are two basic techniques that I want to talk about before I start. The first one is to make the bases the same, so that if you have two different exponents, that the bases are essentially the same. A matches A, then you can figure out what X and Y are by setting them equal to each other. That's technique number 1, to turn those into the same thing. Technique number 2 is changing from exponential format into a logarithmic format. So this would be log base B of A equals E. These are two techniques that you can employ. The book uses both of them. I'm going to show you how to do the second one. The first one first and then the second one in our examples. So hopefully you'll see what I'm doing when I'm doing the examples. Okay, so here we go. In this first one, I'm going to use the technique of making the bases the same. So if I scoot in on this, you'll see that 125 can actually be written as 5 to the third power. So if that's 5 to the third power, and this is 5 to the 3x minus 6. Wouldn't those exponents have to be the same thing if the bases are the same? Yes. So what I can actually state as a statement of truth is that 3x minus 6 has to be equal to 6. So adding 6 on both sides gives me 3x equals 9, and dividing both sides by 3 gives me x equals 3. Okay, I can do the same thing over here with number 2. 8 is 2 to the third power. And then that's raised to the x plus 2 power. 4 is 2 to the second power, and that's raised to the x minus 3. So if I consolidate these exponents, that's 2 to the 3x plus 6. I'm just multiplying with my 3. And this would be 2 to the 2x minus 6. Okay, multiplying across with the 2. So now the bases are the same, and I can then assume then that 3x plus 6 has to be exactly the same value as 2x minus 6. So if I minus x on both sides, and then I minus 6 on both sides, x equals negative 12. So that is the first technique of getting the two bases to be exactly the same thing, and then setting their exponents equal to one another. Now let's try the other technique, like this. Here's an example of that on this page, but I'm going to do a whole problem from beginning to end. All right, number 3. All right. Okay. So we're going to solve this. We're going to find the solution set using a calculator to obtain the decimal approximation, and we're going to round off the answer to decimal places, but only the answer gets rounded, not the numbers on the way. So if I have 5 to the x power equals 134, I'm going to rewrite this in logarithmic form. That's the second technique. I've got it like this. I'm going to write it like that. So I have log base 5 of 134 equals x. So I can find x by finding this value. Now we learned the change of base formula says that if you simply take the log of the argument and divide by the log of 5, that's your base. You can use base 10 on your calculator to do this. So we're just going to use our regular log button. Again, that's just your base 10. It just doesn't say that on your calculator. So we're going to punch in log of 134, which gives us the decimal 2.1271. And we're going to divide that by, and again, this kind of goes off the screen, but I'm rounding a little bit just to write it down shorter. Log of 5, punch that in, you get the number 0.69897. And then if you divide those out, you get that x is approximately, and again, we're rounding off to 2 decimal places like I asked, 3.04. There is another example of this I'm going to show you. But you have to isolate the exponent part first so that you actually have it in exponential form. You need one exponent, or one base, one exponent, and then an answer. So you can see that this one doesn't have those three parts. It's more involved than that. So the first thing I want to do is I want to get it so that it actually just is a bunch of just those three elements: your base, your exponent, and your answer. So I'm going to simplify here. I'm going to add 5 on both sides. So I get 7e to the 2x equals 63. And then I'm going to divide both sides by 7. So I get e to the 2x equals 9. Now you can see I have a base, an exponent, and an answer. Now I'm ready to do what I did before. So I'm going to rewrite this in logarithmic form. So that's log base e of 9 equals 2x. Log base e on your calculator is your natural log button. So we're going to go ahead and use that button now. Natural log of 9 is approximately 2.19722. And to solve for x, we just divide by 2 on both sides. Now we're going to round that off. It's approximately 1.098, rounded off to 2 decimal places. Our answer is still approximately 1.10. Okay. So, all right. Now this one is going to be the trickiest one of all. We're going to solve this using the logarithm technique, which is this one. Now this doesn't look like it's an exponential form, but here's the trick. We're going to take the right-hand side of this equivalence and just think of it as one thing. So this is your base. 2x minus 1 is your exponent. But then we're going to think of the other side as just one thing. This is our, as I like to call it, the answer. Okay? So, if we rewrite this in logarithmic form, it looks like this. Log base 3 of 7 to the x plus 1 power, oops, equals your exponent, which is 2x minus 1. Okay? Now, here's the funky part. We use our power rule now to take this little power of x plus 1 and remove it and then move it into the front. So it then becomes x plus 1 times the quantity log base 3 of 7. Now all of this wrangling is just trying to get us so that we have this right here. When we have log base 3 of 7, we have a number that we can find on our calculator. So I'm going to take on my calculator the log of 7 and divide that by the log of 3. So if I do that and I divide, I get approximately the number 1.77124. And then if I distribute that through x plus 1 and start solving, so I'm just going to round this off to 1.77 just to write it down more simply, not because I'm actually using the rounded value. Subtracting 2, actually we can subtract this on both sides and add 1 to both sides. So you get your x value. I'm running out of space, so I'm just going to go right to the answer, 12.11. And there you have it. That's the last example.